Welcome to today's lesson. We are going to look at images formed. We start with ray construction. When we are drawing the ray diagrams to locate images, it is important that we note the following. Number one, real rays and real images are drawn in full lines. Then number two, virtual rays and virtual images are drawn in broken or dotted lines. Then when you are locating the image, we use 2 or 3 rays from the tip of the object, and where they intersect, that gives us the tip of the image. When the object is crossing the principal axis, then to get the foot of the image, we draw 2 or 3 rays from the foot of the object, and then where they are going to intersect, those rays where they are going to intersect after refraction, it will give us the foot of the image. Now to get the height of the image, you need to join the top and the bottom or the foot, and then you are able to get the image. Then we continue with the symbols that we are going to use when we are using the converging and the diverging lenses. These are the symbols. The first one is for the convex and the second one is for the concave. So when we are drawing the ray diagrams, we are going to use these symbols so that we can be able to locate our image. Then we continue with the characteristic of images formed by lenses, and in this case we start with converging lenses. We start at object at infinite. We have our lens, converging lens. These rays, as you can see, they are coming from far away, from a distant object. After refraction, we have that the first ray will be converged. The second ray that is passing through the optical center goes undeviated. Where they intersect, it gives us the tip of the image, and as you can see, we can be able to get the characteristics of image formed. One, the image is real because there is actual intersection of rays. Then number two, the image is inverted. It is diminished, meaning that it is smaller than the object. Then it is formed at F. And after that, we move to the second type where we have that an object is beyond twice F. So this is our case here. The F is here, twice F is here. So we have the object here. We have said that for us to locate the image, we need 2 or 3 rays. We are just going to use 2 rays. We have the first ray that is parallel and close to the principal axis, as you can see, and it's coming from the tip of the object. That ray after refraction passes through F. Then we have a ray that is coming from the tip of the object and passing through the optical center. That ray goes undeviated. Again, there is actual intersection of rays, and where they intersect, that gives us the tip of the image. So we have our image is inverted. So we have the characteristic as 1, the image is real. Number 2, the image is inverted, diminished, meaning that it is smaller than the object, and it is formed between F and twice F. We move to the third one. We have the object at twice F. We have that this is F. From here to here is focal length. So it means that from here to here is twice focal length. So when we have the object at that position, again, we can draw 2 or 3 rays. We consider the first ray, which is parallel and close to the principal axis. That ray will pass through F after refraction. Then we have a ray that is coming from the tip of the object and passing through the optical center. That ray goes undeviated. Again, where they intersect is giving us the tip of the image. So as you can see, we have this characteristic. 1, the image is real because there is actual intersection of rays. Then number 2, the image is inverted. Then we have that it is of the same size. It is not magnified. Then it is more formed at twice F on the other side of the lens. Then we move to when the object is between F and the lens. This is our diagram. This is our optical center and this is our principal focus. The object is at in between. So we consider the 2 rays. 1, we have a ray that is passing through the principal focus. As you can see, it is passing through the tip of the object. So as it strikes our lens, it is refracted and it emerges parallel to the principal axis. Then we have a ray that is coming from the tip of the object, passing through the optical center. That ray goes undeviated. If you look at these two rays that are emerging from the other side of the lens, they can never meet. So we have to produce them on the other side so that we can be able to know where are they intersecting. Remember, our main aim is to get the image. So as we extend using the dotted line, because now from here to here they are not real rays, as we assume that they are coming from this point. The same case here. Now where they intersect, it gives us the tip of the image. As you can see, because there is no actual intersection of rays, then we are using the dotted lines. And when we use the dotted lines or broken lines, then it means that this image, these lines are virtue. So we look at the characteristic. One, the image formed is virtue, erect, that is upright, magnified, as you can see it is bigger than the object, and it is formed on the same side as the object. Then we move to image at F, at the principal focus. Now we consider the two rays. We have a ray that is parallel and close to the principal axis. That ray after refraction passes through the principal focus. Then we have a ray that is passing through the optical center. It goes on undeviated. As you can see, these emerging rays, they are parallel to each other, which means they can never meet, and therefore the image is formed at infinity. We move to characteristic of images formed by lenses, and in this case we consider the concave or the diverging lens. We have the first case where we are putting our object at twice f. Now if we use our rays the way we've been doing, we have a ray that is parallel and close to the principal axis. After refraction, it is diverged and it appears to be coming from f. Then we have a ray that is coming from the tip of the object, then passing through the optical center. That ray goes undeviated. So as you can see, because there is no actual intersection of rays, as you can see, this one is extended so that you can be able to get the intersection of the two rays. Then this image formed is virtue. It is erect, it is diminished, it is smaller than the object. So in all cases, when we are using a concave lens or what we call diverging lens, all the images formed have the same characteristics and are: one, smaller than the object, that is they are diminished. Then number two, they are upright, and number three, they are virtue, that is they are not real. We go to linear magnification, and we say that this is a ratio of height of the image to the height of the object. Remember, we want to see how magnified our object is. So we can either use the first one, height of the image to the height of the object, or we can look at the ratio of the image distance to the object distance. So mathematically we say that magnification is equals to the height of the image over the height of the object, or image distance over object distance. And we know that V is the image distance and U is the object distance. So for us now to get the magnification, it will be V over U, or HI, that is the height of the image over the height of the object. So we are going to use this formula in our calculations. We can either use the height over the height of the object, or we can use the distances. We move to an example. An image of an illuminated object is found to be 10 centimeters from a converging lens. How far should the lens be placed from that object if the image is magnified 5 times? We look at what is given. One, we are given the image. As you can see, we are told the image of an illuminated object. So whatever is given is the image distance. Then we are given the magnification, which is 5 times. So we are looking for the object distance. We use our magnification formula, m is equals to v over u. We'll press the value, or we substitute the values. We have that 5 is our magnification, then v is 10, so we are looking for u. So u will be 10 divided by 5. You get that u is 2 centimeters. Then we move to the assignment. As you can see, in this assignment, you are supposed to accurate draw, that is by means of accurate graphical construction, determine the position, size, and the nature of the image. Draw. When you are drawing a graph, ensure that you have a pencil, a 30 centimeter ruler. This will help you to draw straight lines. It will help you to draw accurately without drawing thick lines. So draw accurately and use the appropriate scale so that you can be able to locate the image, and make sure that you practice so that you can get the answers provided. So thank you, and let us meet in our next lesson.